on where we left last time. We're using distributive property to start rewriting our expression. So on this one, Zachary is going to rewrite an equation in as few terms as possible, and he looks at two different ways that he can do it. We are telling you up front, both of these ways are correct. They jump to the right answer. What you need to do is go through and explain the reason you use for each method, and then when you think it's going to be more efficient, two methods. So that's all we're doing on this page. We're going to look at these two methods, analyze it, explain your reasoning, and tell us what you think each would be the easiest to use. So we give you guys about 5 minutes because there's a lot of deep analysis. We do want you working together as a group on this one. Good luck. Go ahead. First of all, let me say conversations. I have a lot of really good conversations. To me, one of the most impressive things is most of you are using really good math vocabulary terms. So it's really good hearing you guys use the vocabulary that we need on these. When you break these down, when you look at this second step, that should have given you a big hint as to what the big difference was. Does our second step look the same?
Absolutely not.
It really doesn't. Method one, he immediately broke it into two pieces, didn't he?
Yeah.
Okay. On this one, the first thing he did on this one was he actually used this. What do we call that? What do we call that?
Navy Federal.
The property.
Distributive property.
Good job.
Good.
First thing he did was distributive property. So he used the distributive property. So he distributed that 3 out to each of the inside terms. Then what did he do when he went from this step to this step? That was actually last lesson. We gave you a vocabulary term. What did he do? Yes? What do we call that? What's the math term for it? You are correct. He added the two constants. The numbers without a variable. What do we call that? Okay. Excellent. Thank you. That was combining like terms. So he combined the like terms, in this case the constants, the numbers that didn't have a variable with them. Okay. Then what did he do? When he's talking. Nobody knows what he did? What do you do? Go ahead. Okay, so he then split into fractions, right? So he took that 3 that they're both being divided by, and he divided each term by 3 individually. And just kept that sign, the plus sign, came straight down. And then he was able to say 3x divided by 3, well, that's 3 divided by 3 is
1.
1 times x. 9 divided by 3 is
3.
last step. Simplifying. Okay? On this one, he did this one quite a bit differently. He said, oh, wait, 6 and 3 divide easily together, right?
Yeah.
And 3 and 3 divide easily together, don't they?
Yeah.
So instead of doing all the other steps, he just said, well, I can just split this into the 2 pieces, and then I can take out that common factor, divide both those things by 3. The 6 divided by 3 gave him 2. 3 divided by 3 gave him 1. No. 3 divided by 3 is 1. So I changed my term on the outside of my distributed property to a 1. Well, 1 times anything is just that number, right? Now that 1 times x plus 1 just gave him x plus 1. Then he combined his like terms of 2 and 1 and said, oh, that's 3. And I just have the 1x left. You see the difference in what he did?
I'm trying to understand.
Sure. for being honest. The biggest difference in what he did, and this gets to the second part, because he saw that both of the terms had a number that was easily divisible by the denominator, he just divided it right away. So he split it immediately. If they don't both have something that's going to be divisible by my denominator, then you're going to be better using distributive properties to combine like terms. We'll get to that as we get later into the lesson. So just realize that's the biggest thing. So explain reasoning, I actually listed that above, so you've got all those listed. When do you think it's more efficient? Method one is going to be if both terms divide evenly by the numerator. If they don't, that's when you're going to use method two. So method one is a little more limited. Both those terms have to be easily divisible. Otherwise, I'm going to go to method two, because it's going to help me. It'll work out a little bit better. Any questions on this page? Asher, does it make a little more sense to you? Yeah. We'll get some more practice, so don't worry about it. Okay, on this next page, now we've changed our expression up. It's going to be 8x plus 3 over 4. Nisha and Eldon, you can see, both did it properly. Maeve did it wrong. So, well, first, look at Nisha and Eldon's strategies, see what they did, what's that difference, how did they go about it, explain what Maeve did incorrectly, and then we're going to give you guys a chance to rewrite each expression using the distributive properties. Okay, we'll give you a chance to work on those. But first off, look at these, see what they did wrong, or see what they did differently, then see what Maeve did wrong, and then we'll get some more work on it. So work together on 4 and 5. If you guys finish that, you start on 6, but we'll probably go over 4 and 5 before we move on to that. Give you guys about 4 minutes to work on those.
What is the difference between Nisha and Eldon's methods?
Nisha, she broke it apart and continued to divide it by 4. While Eldon, he switched it around, made it into 1/4 and multiplied it by the same.
So Nisha broke it into what? Terms. Eldon did what? Yeah, no. Oh. Distributive property and did what? He's not dividing by 4, he is multiplying by 1/4, which is the same as dividing by 4. You might understand more. Multiplying by 1/4 is the same as dividing by 4. All right, so what did Maeve do incorrectly when doing her expression? Asher?
He saw that they could be divided by 4 the numerator, but he divided by 3.
Right, she only divided one term by 4. She did not divide both terms by 4. Yes?
Let's see.
Okay, how many were able to do number 6? Okay, only a few of you. So I'm going to do part A, because hopefully all of you got the A. but that should also help you on the next part. So if we use distributive property, what I need to do is figure out what factor is going to go into both of them, correct? So if I have 32 and 4x, what's going to go into both of those?
Well,
4. So I can rewrite that as 4 times the quantity. 32 divided by 4 gives me 8. 4x divided by 4 gives me 1x or x. And then they're both being divided by 4. So I've now rewritten that using distributive property, yes? So now I could solve it if I want to. I can simplify even further. What's 4 divided by 4?
1.
1. So I can now rewrite that as 1 times 8 plus x, which 1 times anything is just that number. So that comes down to 8 plus x. Yeah.
Is it possible to figure out what number is the x?
No, they've got to tell you what x is. If I had an equation, then I could figure it out, but they've not given me any indication what it equals. Until I know what it equals, or they tell me what x is, I can't go any further than that. So does this give you an idea what you're supposed to do, guys? Yeah. You could have broken it into pieces, like on that last page, where they did that first method. That would work because they both go into it. But they specifically said they wanted you to use distributive property. Meaning I needed to figure out some way to get distributive property in there. Okay? So you got 2 left to do. We'll give you guys another 2 minutes. For those of you that haven't finished those yet. I'm walking around and hearing a lot of you guys are really struggling on this whole distributive property thing. Guys, distributive property. If you look back in your book, this was literally the first lesson we did this year. Our new curriculum built a lot of stuff off of the distributive property, partially because this shows good number sense. You're able to recognize which numbers are going together. So they want you getting comfortable using distributive property because you're going to use this a lot in your future. So distributive property just says I have some number that I'm multiplying by some quantity. But it's inside parentheses. That's distributive property. To actually apply distributive property, I'm multiplying the outside number by each of the inside numbers. Well, the arrows should look really familiar to you, yes?
Yeah.
So, on this one, they didn't give it to us in this format. But what did our directions say? Use the distributive property. So because the directions said that, could I go straight to the answer?
No.
No, because the directions said I had to use distributive property. So they wanted me to see that I had that common factor of 4 I could pull out. Why? Because then it actually makes math a little bit easier. 4 divided by 4 is just 1, yeah? Meaning whatever was left inside is my answer. On the second problem, now they've actually given it to me in distributive property, so I have it.
Yeah.
So now to use distributive property, I'm just going to apply distributive property. So I'm going to take my 3 and distribute it to each of those inside terms. So what is 3 times x?
Yeah.
Plus, what's 3 times 1? 3 plus 12. Still haven't done that, right? Over 3. Now I've got some like terms. Can I combine by like terms? Yeah. So I can write that as 3x plus 15 divided by 3. Now I've combined everything that I can. Now I can split it into my 2 terms. So I can say that's 3x over 3 plus 15 over 3. 3x divided by 3 gives me 1. X 15 divided by 3 is 5. So this, rewritten in the form, is this. Here. That's what so all she did was she took this part and broke it into pieces. Which said 3x over 3 plus 3 over 3 plus 12 over 3. So she didn't combine our like terms, but because those are all factors of 3, that one would work. Okay, so our last one, again, we look for our distributive property. It's here. So I'm going to apply the distributive property, put those together. So I rewrite this now as 2x plus 5 times 10, 5 times 2 gives me 10x plus 5 times 3 gives me 5 times 3, 15, all over 3. Again, we combine our like terms. 2x plus x is 2x plus 10x, 12x plus 15 over 3. Now I can break it into my individual terms. So I'm going to use 12x over 3 plus 15 over 3. What is 12x divided by 3? 4x. What is 15 divided by 3? 5. So now it's in simplest form. Part to do that. So that here's your big difference, guys. Going back to that previous example, as to when to split it. Should I split it if I have a 2 and a 3? No, that doesn't work so good, does it? So by combining them all first, did it work well to do 12 and 15 divided by 3? Yeah, because now they're the same factors. So your big key on this one, I would have used method 1. I would have said, oh wait, I have a common factor for each of those terms. I can do that really easy. So I don't have to put them together. This one, I'd say, oh, 2 and 5 with a 3, that doesn't work well. Let me put them all together and see if I get numbers that work better. Does that make sense? Either way is mathematically acceptable. Unless, like this one, where they gave us specific directions we had to follow. Okay, let's go to our next page. So far we've used the distributive property to multiply and divide algebraic expressions by a given value. You can also use the distributive property to rewrite an algebraic expression as a product of two factors, a constant and a sum of terms. You can write any expression as a product of two factors. In many types of math problems, you often need the coefficient of a variable to be 1. So let's explore how to use the distributive property without algebra tiles to rewrite expressions where a coefficient is 1. So a key on this is you have to remember our math terms. What is a coefficient?
Thinking multiply is the y is the symbol.
Number multiplied.
That 5 is
Yep.
to be 1.
So let's look at this. You want to add a quick math term here before we get into it? Factoring. This is something you're going to do in more advanced algebra. So we're kind of setting the stage for your future on this. Is when we write an expression as a product of two factors. That is called factoring. You're going to do this a lot, especially if you start graphing equations, because you need to figure out where your graph is going to cause your x and y intercept. Don't stress about that right now, but just realize we're setting you up for future things by what we're doing today. So this will have a lot of impact in your future. So we're going to start with 3x plus 6. I need you to identify the coefficient of the variable term. Then use the distributive property to rewrite the expression as the product of two factors, the coefficient, there's the key, and the sum of the terms. And then how can you check your work? See if you can actually check it. So go ahead and work through those steps. You've got 3 steps to do. We'll give you guys about 4 minutes. I didn't want to give you guys a lot of time on this. I want you to practice. And the next couple pages are going to help us practice on this. So let's start with the basics. What is my coefficient of this term? 3. 3. So 3 is the coefficient. Well, if I identify the coefficient, that should make it easy. Because if I want my coefficient to be 1, how do I change from a 3 to 1?
Divide by 3.
So, taking the calculate distributive property, well, I'm doing 3 divided by 3, which is x, 1x, which is x, plus 6 divided by 3, which is 2. Oh, I'm sorry.
Why are we dividing by 3?
Because I'm pulling a common factor from both of those.
Something I will like.
My work.
I'm looking it out.
By using the distributive property. So now I'm going to take it. I'm going to use my distributive property to see that it works. 3 times x gives me plus 3 times 2.
Oh,
Good. Then I get what I started with. So have I used distributive property to get the coefficient of 1? You understand how I did it?
No.
That's literally all I do is find the coefficient and divide both numbers by it.
Oh, no. Yeah, to get it.
I'm getting x to be 1. How do I get it to 1? I divide it by 1 foot. I pulled the 3 to the outside. We're trying to get it by itself. Kind of. 1. So, guys, here, let me just give you I learned last class, this might help you. The reason we're doing this is when you get an algebra, you're graphing the equation. One of the big things you do is find the x and y intercept. The way I do that is get my variable by itself. So now I know, how do I get where it's going to cross the x-axis? What value of x would get to get 0?
Divide by 12.
What's the opposite of adding to?
Oh,
Subtracting. So I did 102 plus 2, that would be 0. So that's where this expression would cross by x-axis. That's what x is 0. Okay? Good. And that's what y is 0. So in the expression, 3x plus 6, I factored out common factor of 3 from each term, and we wrote the expression as 3 times the quantity x plus 2. In other words, I divided 3 from each term and wrote the expression as a product of 3 and the sum of the remaining factors x plus 2. That's distributive property. I'm just pulling that common piece out. Yes.
So technically, I'm saying at the answer, you found there the whole time.
Yeah.
Oh, sorry.
And they gave you the answer on the page. As you read the bottom of the page, the answer was right there. Okay. So here's why I said I wanted to do this, guys. Now, so far we've been working where everything worked out real well. We had common factors in both terms, but it doesn't have to be. Okay. So in this example, if I have 4x minus 7, is 4 a common factor for both of the numbers? No. Does that change anything?
Yeah.
No. Doesn't change it. Because if I want my coefficient to become 1, what number do I worry about? The 4. Because I have to divide by 4 to get that to 1. Does that make sense? Okay. So what I'm going to do, because my coefficient is 4, this is the number I'm going to pull to the outside. So I pull the 4 to the outside. So I want my x to be 1. That's what's driving this. Meaning, for both of these pieces now, because I pulled that 4 to the outside, I'm dividing each of the pieces by 4. Okay? So, what's 4 divided by 4? 1. How becomes that? What's 7 divided by 4? One of those few times where the proper fraction is going to be okay. So I just leave that as 4. I don't like improper fractions, but it's actually okay. But you should get it again. You get higher half, proper fractions all the time. After. You could, but that would make this next stop hard. Watch this next step. Let's check this. What do I get when I actually distribute this now? What's 4 times x?
4x.
4x. What's 4 times 7 over 4? Uh-oh, how do I do that?
When you got to make it to the, oh no.
No.
That's
Right.
oh, 7. Same thing.
I'll put the denominator.
What?
And should come.
4 times 7 is 28. 1 times 4 is 4. 28 divided by 4 is
7.
7. Back to what I started with.
Yeah.
So did it work?
Yeah. Just a moment.
There you go. You're sure. Yes. Okay. Questions on this? So again, your key. Start on your coefficient. So using the scrimmage property to check that the expression is equivalent. We just did that here. Now we're going to give you guys a chance to practice. Any expression is a product of two factors. Use the distributive property to make sure what you've done is proper. I'll give you a big hint. When your coefficient is 1/2, remember how you do that when dividing by a fraction or a decimal. You got 4 of them to do. You guys got 8 minutes left. Again, your key on find your coefficient. That's what I'm pulling out. What is my coefficient here?
4.
4. Pulling the 4 out, then I'm dividing each of the individual pieces by 4. So what's
Wait, is that 4?
it is. What's 4 divided by 4?
1.
1 or x plus 5/4 doesn't simplify, so there's my answer.
Hey.
Okay? Where's my coefficient? 8.
8.
Right. X divided by 8
8.
minus 3 divided by 8.
Equals
What is 8 divided by 8?
a 1.
Guys, we do that every time. That's the whole purpose for what we're doing. 3/8 won't simplify, so just leave it.
Okay.
Next one is where it gets a little more complex just because of the math involved. So my coefficient is 1/2. But here's where it gets tough. What is 4 divided by 1/2? How do I divide by a fraction? Good. And then what? Then keep change flip. So change the multiplication. Flip to 1, that gives me a over 1, which equals 8. So that's x minus 8. Fine.
But then how come on A? So why did you do that?
Because 1. Any number divided by itself is 1.
Oh.
That looks funky, so I didn't want to confuse you by writing that. Now my coefficient is 5/10. Let me pull that one out. How do I divide 5/10? Actually, I need to go the other way. 3 and 5/10 divided by 5/10. How do I divide decimals? I don't know. How do you get a whole number? I mean, good. So I've got 3 divided by 5/10. So I need to move it here, but if I move it there, I also. Oh, yeah. So will 5 go into 3? No? Will 5 go into 35? Yeah, 7. So I get into 35, so my other term is 7. So what's half of 7? 3.5. Because, what am I doing? Dividing by 4. Dividing by 5/10. Because when I pull it out, in order to keep it equal, I'm multiplying by half. To keep the term equal, I have to also divide it by half. Okay, guys, let's go to your homework. On 385. 385. You have to watch the video for this. Okay, so a little extra help on your homework. Describe 3 different ways you use distributive property to rewrite expressions. Write an example. When you go back through the lesson, we've given you several different examples. From pulling out common factors to actually distributing it to changing the pieces of it. Here's where it gets a little more complex on this, because partially going to go through the piece on this in the lesson. But you're going to start the fire with 6 logs and then plan to add 3 logs for each hour the fire burns. So that's the number of logs. So I'm just giving you a quick hint. I hate using L as a variable, so I would say X is going to be the number of logs. And so when we get started, we're doing 6, then I'm adding 3 each hour. That's actually the number of hours. We're doing 3 logs each additional hour, so 3 times X. If they decide to go for 2 nights, you're going to rewrite the expression for the number of logs they would need for 2 nights. Remember, you need both parts, the 6 you starts with and the 3 for each hour. Then create a model. So maybe algebra tiles. Remember, you're using X's for your logs and then 1s for the ones you started with. Then you're going to rewrite it using as few terms as possible. For the bottom part, you're going to rewrite each expression using the fewest number of terms as possible. By terms, we're talking the same if they have the same variable or if they have constants. So those would be the same and these would be the same. Don't let the fractions mess you up. Make sure you're paying attention to operations. Those you're adding. Here you're subtracting. Here you're going to need to use the distributive property first. You distribute it out and figure out how many pieces you got. Same thing here. I know technically you can break this one apart since I have a common factor for both of them. So that would be your choice. You can either distribute it out, then combine them, then divide by 6, or you just do it at the start. On your back page, rewrite each expression as a product of 2 factors. The coefficient is 1. In other words, this is the number I'm looking at and pulling that out and then putting what's left on the inside. Remember your operation. If my coefficient is 2/3, I'm going to have to end up doing 8 divided by 2/3. At the end of each school year, you clean out all the school supplies. You have 4 times as many markers and pencils, 3 more highlighters than you have markers, twice as many pens as you have highlighters. And we're going to start at P. So that's the number of pencils. You're going to write the algebraic expression for the number of markers. You're going to put it in terms of P. So for the markers, you know that is going to equal 4 times the pencils. So now that you understand the markers, I've got a term in pencils that I can use. We're going to use that for the highlighters, and then for the number of pens, and then we're going to do an algebraic expression for the total number of writing pencils. So I will give you the hint up front. It's all going to be in terms of the P and pencils. That's what we started with. Hopefully that one makes sense. It's a little bit tougher on the homework, guys. So if you need help with it, please ask, come in at seminar. Good luck.